So to be able to do that, like Polkadot comes up with this architecture. So we have a relay chain. So relay chain, because it relays the messages between these parachains. So it's called relay chain. It's layer 0. And that's the main reason like Polkadot doesn't even have smart contracts. So it's supposed to be like this internet level layer. So internet, it doesn't make any assumptions on the applications that run on top of it, right? So you can run Netflix, you can run Uber, you can run like Facebook. Each application is targeting a specific use case, and then it has its own bandwidth requirement. It has its own I don't know, like architecture. But internet itself doesn't make any assumptions or pose any limitations for that. So it's an open layer for all these specific use cases to run on top of it. So that's what like Polkadot is achieving by being a relay chain. And then layer 1 parachains. So we have plenty of these. So on Polkadot, there are around 40 parachains that are live right now. There's a common misconception it can only support 100, but that's just like that number is coming from like benchmarks that we did like 3 years ago. So now there have been a lot of optimizations. There's a lot of upgrades to the hardware that validator nodes are running on as well. So that number is much more. But yeah, so think of these 100 different blockchains running in parallel and working with each other. So that is Polkadot. And talk about any layer 1 blockchain out there. Think about Ethereum. So Ethereum functionality can be shipped into like one parachain. And think of like 100 different Ethereum style machines that are running parallel to each other. So that's the ultimate, goal of Polkadot. So being able to generalize a lot of like blockchain stuff, having like these different blockchains like run in parallel. And then finally bridges. So again, like the fundamental thing I mentioned about Polkadot is like we don't believe like we are the only chain that is going to be running. There are other chains as well. The Web3 vision is like multi-chain. So we have Bitcoin, we have Ethereum, we have like Cosmos or different kinds of blockchains out there, which are having their own approach towards like Web3. So we should be able to communicate with them, right? So that's what like these bridges do, and these bridges will also run as parachains on Polkadot. I have a couple of questions in. Yeah, so what is meant by state growth? So think about it, like if you create an account on blockchain, okay, so that account has like a balance, right? So this information has to be stored somewhere. So a blockchain state is that, like, what are the accounts present on my blockchain network? What are their balances? Did they create, I mentioned something about like being a proxy, or did they deploy a smart contract? That is part of like the state of the blockchain. Now with Ethereum, the state growth is a problem because if you're deploying a smart contract, you're paying one-time fees. So you're just paying, okay, so this is the fees I'm paying, and I'm pushing that code onto the blockchain network. And after that, every blockchain node has to keep that information and keep replicating it, or with every block, like that data is still there. So there's no incentive for you to remove that smart contract, or even accounts with like very tiny amount, like negligible balance. They can't even make a transaction, but they're still there in the state. So as you keep adding this information to the blockchain, that state, the storage requirement for the blockchain network keeps increasing. Yeah, so Ethereum has this problem. It's an open problem. Vitalik has suggested several approaches to sort of tackle this state growth issue. But again, like this was observed back in 2017, and every blockchain was coming up with a solution to ensure this doesn't happen. So for instance, on Polkadot, we have what's called existential deposit. So if you have to create an account on Polkadot, you should have a minimum balance of $1. If your balance falls below that $1, the account is deleted from the state. Okay, so if you have to create like a smart contract, or like, I don't know, so you can come up with a design decision where you place a deposit, and if you're no longer using that smart contract, you kill that smart contract, and then you sort of get that deposit back. But yeah, so state is that, and different blockchains come up with different solutions to handle that problem. All right, so let's move. Okay, so I won't go, in the interest of time, very in depth about like the architecture. So this is the high level overview. So I showed you like there is a there's like a parachain, all these individual blockchains that are running in parallel. So there's like a relay chain, and relay chain has these validators that are sort of validating like these parachain blocks. Now you might wonder, like, okay, so I am a parachain, I'm also a blockchain. How am I able to run my network? So for that, you would use what's called a collator node. So collator nodes, their job is to listen to the transactions that are happening in the parachain network. They create a block, and then they send it over to Polkadot validators. So the way this works is these collators are not part of the consensus of the blockchain. So their job is to just compile the information and send it to Polkadot network. And for that reason, you can run like a blockchain with a single node, a single node that is compiling these transactions and sending. So typically parachains have around like 5 or 6 collators. Some have like 40 or 50 collators. So that's your design decision, how many nodes you want to run in your blockchain network, how decentralized you want that to be. And those blocks are sent to Polkadot validators, and then they validate the core logic of that.